FSG Academy is not talking about combustion and combustion hybrid cars anymore. So we want to substitute that part here for the FS4A Academy. And we want to present a more practical and bottom-up approach as to how to solve things, because we think that is something that can be improved upon. So, best practices for mechanical engineering overall. Quite a simple statement, but it's true. In order to win the race, you first have to finish. So please don't change everything in your car. Focus on key areas that you want to improve on your car, especially if the things worked already quite well in the past. It's more important to get your car running at least 2 months before the competition, so that you can test it. Also very important, about 4 weeks before the competition, so in our case for FS Austria that is June 21st, there is the deadline of the vehicle status video. So there you have to present and upload a video of your car where it is starting under its own power, it's accelerating, making a 180-degree turn and coming to stop again. And that is a very strict deadline. If you cannot upload such a video, then you are going to be deregistered from the competition. So your car definitely has to drive. And also very important tip, if you finish your car 3 months before the vehicle status video deadline, make a vehicle status video as soon as possible. You never know what happens. So for example, we had teams where all the inverters broke and the car was not driving anymore, so they couldn't make a vehicle status video. As soon as your car drives, make a video, full stop. And then just test the car, test the car, test the car. It will help you improve much more than anything else. And if you want to change your design during the testing phase, do that. But the most important thing is that your car runs and that you can test it. Best practices of chassis design. As I said, this is only very short input now, because there's already a full slide for SCS related topics in the FSG Academy. But I can definitely give you the tip to use the SCS template as soon as possible in order to make sure that your chassis design works out. And this template, of course, will be reworked every year. Just use last year's template for the design process. It's definitely good enough. Also use the FSG rule questions tool, but it's not intended for general design questions. So you can post rules questions, of course, but it's not intended that you post a picture of your design and ask, is this a good design or is it a bad design? The questions tool is about, we don't understand this question, is this option correct or is this option correct? Because for us it's not clear. That is a rules questions, and that is what is going to be answered at FSG. If you have general design questions, as I said, FSG won't answer them in the rules questions tool. Instead, you can contact us. For example, in the FS Austria team, there is specialists for SES, there is specialists for EAD. You can write them an email and ask about their opinion. Very important chassis design related rule is the alloyed steel. You have to be aware that if you use high strength steel, then you have additional requirements. Really think about it if it's worth for you. In most cases, it will work fine with the standard steel. Just use that, and then you don't have any additional problems. If you are welding aluminium, so that is, for example, in the front tube of a monocoque car, also be aware you have additional requirements. If you don't want to deal with it, just use steel or aluminium and don't weld it. Also, if you're making laminate structures, doesn't matter if it's about the chassis and or the accumulator, be careful with asymmetric and non-isotropic laminates. There have been rules updates there, and also there you have additional requirements. So the easiest thing definitely is if you have plus minus 45 degree and 0 and 90 degree fibers in the same compositions in your skin, and if the inside and outside skin of your laminate is symmetric, then you don't have any issues.
Quite a lot of rules have changed with regard to bodywork and the bodywork.
Here you can see quite a lot of rules have changed with regards to bodywork and the bodywork radii. So T1.1.2, as you can see here, everything which is highlighted in green is something which has been added to the rules. So there is now a definition for the bodywork, and in side view, in any side view, so including any side view section, in front of the cockpit opening and outside of the areas that is defined for the aerodynamic devices, all parts of the bodywork must not have external concave radii. What does that mean? If you have a monocoque which has like a sloped nose design, like everybody has basically, maybe I can write it here. So you have a very basic monocoque with like a step here, and here is the cockpit opening with the steering wheel, and here you have your front wheels. Many teams have used this space here for their front suspension components, or especially the shocks. And for that, many teams have created like a cutout in the monocoque. That is still fine, but you have to cover this cutout with a cover in order to make sure that the overall silhouette of the bodywork, so the monocoque including any fairing, does not have concave radii. So this, for example, here and this here would be a concave radius, and you have to cover that up. And as you can see here in the version 1.1, so this is now your first peek into the rules version 1.1. They are not yet published, but it says here any gaps between the bodywork and other parts must be reduced to a minimum. So for example, if you have here a pass-through for your suspension part, of course you can do that. You can also make sure that the pass-through is big enough for the whole suspension travel, but it must not be significantly larger than what is needed for that to pass through.
Please go to the FSG website, because
if you have any problems with this very rule, please go to the FSG website, because I'm not responsible for that rule change. Just so you know. So if you have any questions with regard to the T232 bodywork rule, FSG rules question tool. Also, you can see here T241 with regards to external radius of devices. This has also been clarified in version 1.1. It is now limited to edges that could come in contact with any standing pedestrian without the standing pedestrian reaching towards the vehicle. So anything that you could brush up against with your arms or your legs, these radius have to be rounded. 3 mm radius on forward-facing edges, 1 mm on all other edges. And all the other requirements for especially aerodynamic devices have been lifted. So T241, and there is still one rule remaining for the nose cone radius, but that's it.
many of you have seen it in the
Best practices with regards to envelopes. Many of you have seen it in the rules, I hope. The definitions for the envelopes have changed, but the intent from our side remains exactly the same. So for the rollover protection envelope, we want to have critical components, which includes the driver, of course. They need to be protected by a suitably strong structure. And the figure in the rules give a good example on how we understand the rollover protection. That is also a very legitimate rule question. If you are not sure, please submit an FS3 rules questions about your design if it fulfills the requirement or not. The second envelope is the surface envelope. This is basically about components that should not stick out from the car. So this is about fuel system, hybrid system, and I think it's also about the autonomous driving sensors. And we have made a rule change in version 1.1 because it was unclear. The lower boundary of the surface envelope is the projection in side view of the rollover protection envelope. So we remove the word horizontal, so it's not a horizontal plane at the bottom of the car. It's a side view projection of the rollover protection envelope. Again, I hope that the FS rules version 1.1 will be published very soon. It should be online by Tuesday, I hope. Best practices with regards to suspension and steering. We have made the rule change again that alternative fasteners may be used for suspension and steering, because last year that possibility was not really there in the written word of the rule. Be aware, suspension system is everything which makes the wheel go up and down. Steering is everything that makes the wheels turn, but everything which turns the wheels in the driving direction is either the drivetrain or the brakes. So for drivetrain and brakes, if there is a requirement for bolts according to T10 rules, you must not use them there. You must only use alternative fasteners in suspension and steering. Equivalent fastener means that the fastener has adequate or equivalent yield strength, equivalent ultimate strength, and that the load path of the bolt, especially the bolt head, is suitable. Which means, for example, you must not cut off the bolt head until it's only like 1/3 of the height. That will not work. The bolt head might shear off. And of course, good engineering practice must always be applied, especially for bolts. The material choice has to be suitable for the job. Also another rule change, the steering rack must be within the rollover envelope, but also here we made a change in the 1.1 version. This only applies to the stationary parts of the steering rack, so basically the steering rack housing, which has to be properly mounted to the chassis. That part needs to be within the envelope, and of course all the rack itself, and of course also the track rods, they may stick out, of course. Best practices with regards to brakes and wheels. These are the most important safety, active safety parts of your car. Please keep it conservative, because a flying wheel or a disintegrating brake is not a good recipe for winning the competition, believe me. Also, especially with anything which rotates, especially the wheel hubs, you have to consider fatigue strength, because for every rotation that the wheel is turning, that is a full load circle, bending it upwards and then bending it downwards again. And many materials, especially aluminium, they might be able to take the load like 100 times or even 1,000 times, but they are not able to take the load like 1,000,000 times. They are going to crack at some point. So you definitely have to consider that in your design in order to to make sure that the wheels stay on your car. Also, again, I think it was said in the FSG Academy already, but if you're using floater bolts in your brake disc, you may do that. But if they are designed with snap rings, so retaining rings, you may only use them if they are original equipment manufactured. So you must not manufacture your own brake disc floater with a snap ring. That is not allowed. Also a rule change with regards to the brake pedal. The pedal face must be metal, just like the pedal itself. And the pedal face, I have seen a lot of questions. The pedal face is like that what is being pressed with your shoe sole. So if you have like heel guides on your pedal or like guides on the side, that is not considered the pedal face, only the forward facing area. And also, of course, it's called a brake pedal and not to brake something. You have to be aware that scrutineers may test your braking system, and this includes stomping your brakes as hard as they can. So be aware that Austrian scrutineers will take full force on your brake pedal and it must not brake. Best practices for firewall. There's basically three main requirements for the firewall. It has to be fire resistant, of course. Be aware you can test it yourself. So you can make a test sample, put it underneath a Bunsen burner, and you can look up the test requirements for UL 94V0. And we would suggest that you film the whole process, making sure that all the flame times and waiting times are correct. And in order to validate that, you should have like a clock running in the background. And for documentation requirements, you can, of course, bring the whole video and the test samples to Scrutineering. And also, if necessary, you can send the video before the competition. Second requirement for a firewall is it has to be rigid. So that is written in the rules. Firewall has to be made from a solid and rigid material. In order to make that work, just using like 0.5 millimeters of aluminium won't work out. What you can do is either you make it a sandwich blade, laminate, or you use geometric elements like stiffening grips so that it's suitably rigid. And the third important requirement is that it must seal against the passage of fluids. In order to make that happen properly, please use proper flanges and sealants. Just putting lots of tape around the firewall is not good engineering practice. And also you have to remember you have to remove the firewall for scrutineering so that we can see the components behind it. And it's just much more easier and more consistent and more safe if you have like a proper flange and a proper seal. Best practices for the cooling system. Be aware all components of the cooling system must be rated for at least 120 degrees centigrade, or for the temperatures that you might have in your like oil cooling system, so it might be above that. But be aware every component has to be rated for that temperature. That includes also electric vehicle cooling systems. So it doesn't matter if your like battery pack will never reach like above 60 degrees. Your cooling hoses, water pumps, etc. It has to be rated for the temperature. As I said before, the requirement for plain water is only for the combustion engine. Other cooling systems might use plain water, air and oil as the coolant. And here you have a nice picture of a car that was not cool anymore. They lost the chance of winning the competition. They were really fast, but 2 laps before the end, the finish line, they had the whole car going up in vapor. It was. So keep it cool, climate change is real. Make your radiators and fans larger than you think you need it. it's always better to have it one size larger in this regard.
What is our goal in scrutineering?
So now some tips for mechanical inspection.
Of course, we still
What is our goal in scrutineering? We have to guarantee adequate safety. Of course, we're still talking about race cars, but race cars can be incredibly safe if you do it right. Our second goal is to get as many cars as possible on track, because Formula Student competition doesn't make any sense if the cars are not driving. And the second goal for us as scrutineers is keeping it fair for everybody. So we have to make sure that the rules that are there, for example, to limit the size of your aerodynamic devices, that everybody is actually adhering to that limit in order to keep it fair. How we do it? We're using the inspection sheet. You can find that on our homepage. It's to be found under rules and documents. We are going to have online always the inspection sheet from the last season. So in this case, it's the 2023 inspection sheet. And we are going to upload the new version as soon as possible. This is going to be, I guess, 4 or 5 weeks before the competition. But definitely the old sheet will work better than no sheet. Also, please consider reading the rules. We also have to read the rules as scrutineers, and even it might be necessary to check up on the rules during the competition for us as well. Also, always be aware, you don't get points for scrutineering, but without scrutineering stickers, you don't get any dynamic points either. So it's really the first step of the dynamic competition. Some more tips for mechanical inspection. How can you prepare? Definitely read the rules. If you're not sure, ask a rules question. As said before, you can use the FSG rules ticket system. We have access to that as well and are answering there as well. But you can also, of course, write to the competitions themselves. If you are in doubt about your design, please keep it conservative. Nothing is more infuriating than breaking your car and not being able to compete. If you find something that doesn't look right, don't build it like that. Change it. If it doesn't look right, in most cases, it isn't right. Also very important, do a dry run mechanical inspection or overall inspection with your alumnus if possible. And if you have the chance, go to pre-events to just, again, test. This includes scrutineering as well. And at the event for mechanical inspection, you have to bring all your documents, so your impact attenuator data sheet, your SES, and your ESF, HSF, all the documents. At least for FS Austria, they don't have to be printed out. It's okay if you have them on your laptop, but just be sure that your laptop has juice. Also, if you had posted any rules questions, bring them with you as well for reference. You also have to bring all your test samples, so especially your chassis, 3-point bending and shear test samples, all that. Also, you have to bring spare parts and equipment. Because you will run up with challenges during scrutineering, you will be asked to change things, and the more material and tools that you have with you, the easier and faster it is for you to repair it. And also you can help out other teams. We really want to encourage you to work together in this regard with other teams at the competition. Normally it works really well. So if one car maybe doesn't have like the correct impact attenuator, I think we can find solutions at the competition, because everybody helps everyone. And yeah, that is already it for the second session. We are now again going to Q&A.
So, the labor is technique, right? Here. Your microphone is online. Okay.
Ich höre jetzt nichts.
it should be online. Hello. Again.
Wir haben keinen Sound, nein.
But my microphone is working.
Ich höre nichts. Also ich höre jetzt, sobald ich was höre, sage ich es euch. Probiert es einfach aus.
Mach wieder das rechts unten, mach Schriftzug. Hörst du was?
Nein? Jetzt haben wir wieder 2 Schirme, aber ich habe nichts auf dem Beamer.
Okay, let's try microphone number 1 again.
Ich habe noch
Okay,
keinen Sound.
let's
Ja,
try
Sound.
microphone number 1 again.
Test, 1, 2, 3.
So, sorry for the quick technical interruption. Now we have 2 microphones.
Jawohl. So, sorry for the quick technical interruption. Now we have 2 microphones. I have my colleague over there who is going to ask me the questions.
So, first question from our from the student teams. The best practice seen with respect to firewalls and something that can use efficiently, with any suggestions?
For combustion cars, I think aluminium firewall, aluminium honeycomb is a good material because you can easily cut it to size. For electric cars, you also have to incorporate the insulating barrier. There are many solutions for that, but I think the easiest one is the Kapton tape. You can get that in suitable thickness, and it will be strong enough to work out.
So, next question again to firewalls. What materials are the best to use to construct a firewall for a car, especially with regard to adequate stiffness?
Yeah, this I already answered during the presentation. That was one of the questions that came in before, so that is already answered.
So, let's go to the next topic about cooling systems. For the cooling system, to what extent can the cooling tubes run outside for the chassis?
Generally, there is not really a limit on that, to my knowledge. You have to make sure that the driver, when he enters and exits the car, that the driver doesn't touch hot cooling system lines. But apart from that, you are allowed to run the cooling system to wherever you need it. Also, if I remember correctly, the cooling system, especially the radiators, they don't have to be within the surface envelope, so you can put them really far to the side or to the back, wherever you need it.
So again, a question about cooling. Are we allowed to have accumulated cooling holes?
So again, a question about cooling. Are we allowed to have accumulator cooling holes in the sys? And is there a rule specifying the diameter of the area of those holes?
That question also came in before. Generally speaking, if you have any kind of hole in the site impact structure, you need to document it in the structural equivalency spreadsheet. And we will check that document before the competition in detail. If you make a hole, maybe I can draw it here. So generally speaking, you have like your site impact structure, which is this area here. And you have the panel height here. And this is what you put into your structural equivalency spreadsheet. And this area has to be equivalent to at least 2 steel tubes that it replaces on the side. And if you now make a great big hole inside here, the resulting panel height is only this height plus this height. So effectively you are reducing the panel height by the diameter of your hole. And also please keep in mind, don't do something like this, where you put in a very elongated hole, because now of course you think your effective panel height is not that much reduced, but you have lost a lot of integrity. The top part and the bottom part are not connected properly anymore. The load path is really bad from here to here, so that is not good engineering practice. So keep that in mind. If you're not sure, ask a question. We are very happy to answer it, even if it's just basically design review question. FS Austria is happy to answer it.
So, next question. Can 2 attachment points with 15 kilonewton in any direction instead of using 1 attachment point with 13 kilonewton in any direction to be used to fasten the TCAC?
Generally speaking, 1 connection point, for example, if you look at the main hoop, 1 connection point always has 2 bolts. But this is considered as like 1 connection point. So if you have like a tube and you have on that a bracket with 1 bolt on the one side and the bracket extends to the other side as well, you have the second bolt here. This is considered 1 attachment point. And of course you can apply the same logic to accumulator attachment as well. If you have like a bracket which is a little bit longer, you can have 2 bolts inside it, 15 kilonewtons each, and it's considered to be 1 attachment, yeah.
Okay, thank you. So let's go to the topic aerodynamics. One advice for our teams. For aero development, what are the most important points to emphasize?
Yeah, I also had the possibility to write something before. My first tip is don't just blindly trust your computer fluid dynamic simulations. At the end of the day, it's garbage in, garbage out. So if you're not a specialist with regards to CFD, you should be really careful about the results that you're getting from that. From my personal opinion, it's much better to start small and try to understand that very basic aerodynamic concept. And once you have understood that, make it more complex from there. And tip number 3, from my point of view, 1 day of testing with some different flaps and gurney strips and also some just sheet metal and tape. 1 day of testing will be worth more than weeks spent in CFD. So get the car running, get out there and test your aerodynamic devices. From my point of view, it's much more significant than CFD.
Okay, let's go on with aerodynamic. For aerodynamic devices, how the design of CFRP and GFRP to withstand the deflection imposed by regulations without adding too much weight?
That is also, of course, a very general question, but I would give the tip to start with a lecture. So I first learned working with laminates using the Konstruieren mit Faserverbundwerkstoffen book. I'm not sure if that's available in English as well, but just try to find books on that topic. Also, try to get in touch with people who have already done it, either alumni of your own team, or if that's not possible, try to get in touch with other teams and help out each other. After all, learning something is all what it's about.
I think there was another question about aerodynamic devices, also how to make it stiffer. My last tip about that.
I think there was another question about aerodynamic devices, also how to make it stiffer. My last tip about that is take inspiration from aerospace. So for example, if you have a wing profile in aerospace, it's flat on the bottom, and in order to make that stiff, you can make ribs here in the middle, which join the upper and the lower portion of the section, and it makes it much more stiffer. Of course, you can also just fill out the whole section with like foam core material. It will improve the overall stability greatly.
So coming from aerodynamic to the monocoques, how to start your first monocoque? Basic principles, basic equipment, mold making, test sample says, are aluminium, Kevlar honeycomb easier to compare to wood?
This is impossibly to be answered in the time here. I could write the whole book about it, but basically here as well, start out with books that are already available. Get in touch with persons who are knowledgeable in that field. One of the most important things for you as a former student team is check out which kind of materials and processes that you have access to. So for example, if you don't have access to an autoclave, or the autoclave is like accessible to you in just like 2 days for the full year, don't use pre-break material. Use resin infusion instead, or just wet laminating instead, because you should really work with the materials and processes that you have good access to.
Sometimes stuff just go wrong.
Next question.
Again, a new question which came in. Sometimes stuff just go wrong. In what ways is repairing a broken monocoque okay? Are tested required?
There is quite a lot of ways where laminates can be repaired. So in the most basic case is that you have like delamination of your laminate. So you have your outer skin, your inner skin, and some kind of core material. And the laminate only works if you have a proper adhesion between the inner and outer skin through the core material. And sometimes it happens that it separates here and that it moves around. That's quite relatively easy to detect, because if you hit against the laminate with like your finger, so like that, or even with a coin, it will make a very distinctive sound. So where the laminate is working out correctly, it will give a much different sound than where it's delaminated. And in order to repair delamination, what you can do is you can drill a lot of small holes, so like 1 millimeter holes every like 1 or 2 centimeters, and inject the broken area with lots and lots of structural adhesive. This is done like all over the world, even like spacecraft are repaired like this. And if you have like something more is broken, so for example, consider that your laminate really has a big hole inside of it. What you can do is, for example here, let's consider this is the inside. You could make a laminate plate, or even you could also use steel. You bond it onto the inside, you make sure that the patch is at least as strong as the skins that you want to repair. So you get in contact with the reviewer who checked your SCS. You get in touch with them, and you make equivalency calculations that the skin is at least as strong as the one you want to replace. You also have to make sure that the bonding connection is good as well. Then you fill out with any kind of filler material which is strong enough for the core. And then on the outside you use wet laminate to repair the section. And of course here as well, the laminate for the repair has to be at least as strong as the original laminate. And then that's a completely fine solution. Make sure the competition that you're entering also accepts it like that, but it's definitely possible, yeah. Next question.
So, if we have a CFRP monocoque and an electric four-wheel drive, how do we insulate the HV wiring for the front tires?
That is a good question, because there is like 3 solutions to that, or maybe, yeah. The high voltage cabling has to be within the envelope, except for the minimum part that is going to the front wheels, as far as I remember. So you have to have it inside of your monocoque, basically. Yeah.
Maybe I can answer this. Yeah, for the till the front wheel motors, you have cables. These are cables. You have to use a firewall because between the cables and the driver. This is normally done when you use an aluminium pipe and do some Kevlar outside. Everything's fine. You can go with this solution till to the front suspension. There you have to fix the cables, and then you can go outside. The cables from the monocoque to the motors, it's allowed that it's not inside the crash structure. Okay, I come over here. And yeah, that's all. I don't think where you have to isolate it anywhere, because if you have contact between the cable conductors and your monocoque, you have a problem. If you have a contact between the shielding of the cable and the monocoque, yeah, it's not good for EMC reasons, but it should. So there is no rules violation, and normally it works most of the time. Yeah, and that's all.
So, jetzt habe ich einen Schluss verloren. Okay, what is the next question?
Tischstuhl, jetzt. Okay, what is the next question?
Let's go with a deeper rules question about rule T10.1.5. In which mechanical properties do we have to show equivalence in comparison to critical fasteners?
Yeah, this has been included in my presentation and is there in writing. Then I say here the next question, if I combine the seat and the firewall, that is generally not a good idea, because if you test with the cockpit templates, you are allowed to remove the seat in order to make it fit, but you're not allowed to remove the firewall. So if it's one single part, seat and firewall, it has to stay inside. So keep that in mind. Your templates have to fit with the seat included in the car. and you want to put in additional parts. And you want to make a bracket through the firewall in order to make that fit. Yeah, in that case, I think you are limited to either using the chassis to attach that stuff, or you can use bonding on the inside so that you don't have bolts penetrating through the firewall, which is not allowed, especially for electric cars, because there has to be a full insulating barrier on the firewall, right? Yeah. Alternative is in your firewall, if you have bolts sticking through, basically you need an additional small firewall piece behind the bolts, which are protecting the bolts. So that is the solution.
Okay, next question. How should we test the force on MH supporting points, like hand calculations, FEA, or physical testing?
Generally, for us, we need to check it in the document review process. And the easiest thing for us to check is a physical test, full stop. Yeah? The next easier solution is a hand calculation, because it's easy to see step by step what you did. We really don't like FEM calculations, not because we think that they are a bad tool, but because it's really, really difficult for us to check every step and make sure that it's actually says what you wanted to say.
So, how strongly do you recommend to students to build and include a built-in wireless telemetry system into the car that could transmit data to a laptop?
To be honest, that is up to you. Of course, it will help you in the testing phase. If it makes your car faster because you get much more data to work with, do it. But really, it's up to you. That's your decision.
This is very difficult to make.
A question about a firewall in frame space chassis. This is very difficult to make, a current firewall in this type of chassis. Do you have a good tip for that?
Yes, indeed. So, if you consider your space frame chassis. So you have like your side impact structure with your front hoop and your main hoop. And then it goes from there. And somewhere in this area you want to have a firewall. So the first thing that you will need is a bottom for your, I guess, it doesn't really matter if it's like the battery or if it's the fuel system. You will need here a bottom plate. And the easiest thing to get that in from my point of view is if I make a cross section here. You have the tube, and then you weld on a sheet metal bracket, and then use some kind of plate. So, of course, in motorsports, some kind of sandwich plate, and either use bolts, or you can also, of course, just bond it onto the bracket there. And the same solution you could also use for the firewall. So if you have like a firewall right here, I would encourage you to weld in like a bracket, a flange basically, into your chassis, and then bolt a flat firewall to that flange. And then you can also make the firewall itself a bit smaller, so that you can put it in and out. So I think that should work out fine. Next question.
Next question about rule T 4.6.2. If heat-resistant material is in the firewall with proof that the temp is always below 60 degrees, why is the convection part 25 millimeter air gap of the rule?
I have talked about it before. From my point of view, the 25 millimeter air gap is only necessary between hot parts, for example, the exhaust manifold of a combustion car, and the firewall. So if you don't have hot parts, you don't need the air gap. So that should answer it.
So we have rivet nuts in firewall to mount a second part of the firewall. Is a rivet nut with bolt is considered as open hole in a firewall?
Generally speaking, any opening which has been filled by a bolt or a rivet nut is not an opening anymore. The only thing that you have to make sure is for electric cars, you must not have metal parts going through the firewall. So for electric cars, that's not a good idea. You have to have a insulating barrier beneath that. But for a normal firewall, this is completely fine. So as I said before, if you have like the bottom of your car, you put in some kind of flange, then you can put here your rivet nut. That is completely fine. And then you have your firewall and use a bolt to connect it here. That is actually a very good design, and that is how it's done, basically. And if you have an electric car, you can put in here additional piece in order to insulate the rivet nut. Then it should work.
So, are screws inside gearbox connecting carrier and with wheel hub considered as critical fasteners?
The critical fastener is anything which keeps the wheel inside of the suspension upright. So if you need like gearbox fasteners in order to make that happen, in order to keep like the whole thing together, then from my point of view it's considered a critical fastener. But maybe if that is like a non-standard design, it would make sense if you make a FSG rules question and include a drawing of your solution for better understanding.
Okay, the UL 94 Win0 testing. If we do the test by ourselves following the normative procedure, is the documentation of the test results a valid supporting material at the event?
Yes, of course. But you will need, I definitely encourage you to have video proof as well, because if you yourself are writing a test report where it says it is valid, that's not going to be enough. So either you have like a test report from a third-party testing organization which writes it down like that, then of course that's okay. And if you test it yourself, please make video and photo proof of your test and bring that with you.
We need firewall between the driver's head and HV.
So, sorry, I will highlight it. We need firewall between the driver's head and HV. Is a carbon monocoque covered in the fireproof fabric considered as a firewall, or do we need to add an aluminium plate?
The requirement for electric vehicle firewall is that it includes the 0.5 millimeter aluminium layer. So you need to add that to your laminate. But of course you can incorporate directly into your laminate, and you may also of course use it in for the strength of the laminate. So include it into your test sample, your bending test, and just use it as part of your laminate, and it should be fine.
How many more questions do we have, because we're running out of time? I'm starting with the last two questions.
How many more questions do we have, because we're running out of time?
I'm starting with the last three questions for this session, as we have 3 minutes left. So is there a specific list of things that scrutineers revise at the competition? can we as team have access to that list in order to simulate it beforehand?
Yes, there is a list. It's called the inspection sheet. I already said it in the presentation, and we very much encourage you to simulate your tech inspection before the event. I can show you right now on my screen. So if you go to our homepage, FS Austria, at this point it's called FS Austria 2023. We will update to next year. And then you go to Rules and Documents here on the left. And here you can find all the documents, including, if you scroll down, here you have the inspection sheet examples for both combustion and electric class. And if I open that here, you find here the inspection sheet. As you can see, this inspection sheet is used basically all over Europe officially for these 3 events, but other competitions also use that exact inspection sheet.
So, is there a possibility to be approved or checked by the scrutineers in the process of production, means a pre-season?
So we don't offer that like an official service, but what you can do is get in touch with your alumni and maybe get in touch with officials that may live near you. So for example, I live in Vienna. I'm very happy to visit any teams in Vienna and just go over their car. And maybe you have luck and you can find officials in your area as well who are going to help you out with that.
Yeah, thanks a lot, Hockey, for your questions and answers. Basically, we make some minutes a break, and all questions are left will be answered afterwards. So stay tuned. Also, 1 or 2 days after the FS4A event, and see you in some minutes.
Thank you.
So, Holger, Kakao. Wie machen wir das nochmal übergeben? Soll ich dir das Mikrofon geben oder